Okay, this question. Octane and isooctane are structural isomers with the molecular formula C8H18. The displayed formulas and boiling points of octane and isooctane are shown in figure 2. Okay, give the IUPAC name for isooctane. So let's look for the longest straight chain. Sometimes exam board will put them as if they're going around corners. But there's that there, and then I've got a methyl group here, and a methyl group here. So that's going to be a trimethyl, and that is on carbon number 2, 2, and 4. So it will be 2, 2, 4, trimethyl. 1, 2, 3, 4, 5, pentane. Okay, so these can be separated in the laboratory. Name a technique, or this is going to be distillation or fractional distillation. And outline how this separates isooctane from octane. Okay, this is all about the boiling points. Okay, so isooctane has a lower boiling point, so it will evaporate first. Which will evaporate first. And therefore reach the condenser. Okay, and that obviously means that it is going to be condensed first. So therefore will condense and collected first. There you go, that should do that. Yep, distillation, low boiling point, and will condense first. Okay, right, onwards. Isooctane is added to petrol to increase the octane rating. Write an equation for the complete combustion using the molecular formula C8H18. So C8H18, so combustion is with oxygen, which gives you carbon dioxide because it's complete, and water. So we use MACHO here, so Ma is metal and any other element. Well, we haven't got a metal, there's no any other elements except for, and then the CHO, carbon, hydrogen and oxygen, so we balance them in that order. So 8 carbons on the left, so with balancing, remember it's the big numbers before, and then the hydrogens, I've got 18 hydrogens on the left, 2 on the right, which means I need 9 water. So again, because we're balancing, it's big numbers that go before. And then the oxygens, so 2 8s are 16, plus 9, that is 25, which means I need 12 and a half oxygens here. Okay, part D. Explain how a catalyst works. So a lot of this stuff you either know or you don't. So it has an alternative pathway. With a lower activation energy. So there's your 2 marks there. Carbon monoxide is produced when incomplete combustion takes place in engines. Write an equation to show how these pollutants react together in a catalytic converter. So CO reacts with NO, and again, you either know this or you don't. This converts it to carbon dioxide and to nitrogen. So we remove 2 pollutants and kind of produce one that's climate change or greenhouse gas. That just needs balancing. So I can put a half there, or I can put 2s in front of the CO, NO and CO2. Okay, platinum, palladium and rhodium are metals used inside catalytic converters. A very thin layer of this metal is used on a honeycomb support. Explain why a thin layer is used in this way. So this is to use a small amount. Okay, and that's basically because these are precious metals, they're really expensive. And the second one is it maximises the surface area. Surface area. Okay. And then finally, oleic acid is a straight chain fatty acid obtained from plant oils. Isooctane can be made from oleic acid. The skeletal formula is shown below. Okay, so we've got this molecule here. Let's just identify the functional group. So this bit here is a carboxylic acid. And of course, this bit over here is an alkene. Identify the reagent that could show that it is unsaturated. So unsaturated means that it's a carbon-carbon double bond. The test for a carbon-carbon double bond, hopefully you remember, is bromine water. And with this, because we have a double bond, what we would see is it go from orange or yellow to clear and colourless.